Hey Math 137, what's up? In this video, we're going to be exploring some special values of the trig functions. There are some special angles for which we know the exact values of the trig functions, and those are values that you're going to want to eventually have memorized. It is possible to understand where these values come from. It's not necessarily essential, but I did want to take some time to show you where these values came from. They come from two very special triangles, learning about right triangle trigonometry, and two very special triangles, the first of which is what's called an equilateral triangle, one in which all of the sides have the same length. So again, this is an equilateral triangle. All of the sides have the same length, and so we can take all of the sides to have length 1. And also, all of the angles have measure 60. Remember, the central angles of a triangle have to add up to 180 degrees. And so if you take 180 degrees and divide by 3, you get 60 degrees. So all of our angles here have degree measure 60 degrees. Now I'm going to take this triangle and I'm going to cut it in half right down the middle. Okay, and it's going to make another new special triangle. It's going to be a right triangle now. When I cut this in half, it makes a right angle. So now this angle is 90 degrees. This angle wasn't affected, it's still 60 degrees. And then the angle on the top here, we cut it in half, so it's now 30 degrees. The hypotenuse of this right triangle has length 1. It's just this old side here. The base of this right triangle has length 1/2. I just took this side and cut it in half. Now this unknown side we can find using the Pythagorean theorem. We know that 1/2 squared plus x squared is equal to 1 squared from the Pythagorean theorem. We can solve for x here, get x squared is equal to 1 minus, when I square 1/2, you get 1/4. So that gives you 3/4. And then when I take the square root of both sides, again, if we were just solving a quadratic, we'd have x is equal to plus or minus the square root of 3/4. But since this is a side length, we know that we just need the positive root. The negative root is not relevant in this application here. And when I simplify, we get square root of 3 over 2 using properties of square root. So now we have a length for the height, root 3 over 2. And now we can start to write down some of the values for our trig functions. So remember from our right triangle definitions, let's see, we're going to start with 60 degrees. Actually, let's start with 30 degrees. We're going to need sine of 30 degrees, cosine of 30 degrees, tangent of 30 degrees, and then we're also going to need cotangent of 30 degrees, secant of 30 degrees, and cosecant of 30 degrees. So relative to the 30-degree angle, the 1 is our hypotenuse, the 1/2 is our opposite side, and root 3 over 2 is our adjacent side. Sine is opposite over hypotenuse, so sine of 30 degrees is 1/2. Cosine is adjacent, root 3 over 2 over hypotenuse, so root 3 over 2. And tangent, didn't leave myself very much room here. Tangent of 30 degrees is opposite, which is 1/2, over adjacent, root 3 over 2. And when we simplify that, you get 1 over root 3, or root 3 over 3 if you rationalize the denominator. Cotangent of 30 degrees is adjacent, root 3 over 2, over opposite, adjacent over opposite, that's cotangent. That simplifies to root 3. Secant of 30 degrees is hypotenuse over adjacent. That's 2 over root 3, or if you rationalize the denominator, get 2 root 3 over 3. And then finally, cosecant of 30 degrees will be hypotenuse over opposite, which reduces to 2. Okay, so those are the special values of our trig functions for 30 degrees. Again, we got them from this 30, 60, 90 right triangle. We can also find the trig values for 60 degrees. Go over here. So looking at that same right triangle, we want sine of 60 degrees. So now, I guess relative to 60 degrees, these sides have changed. The hypotenuse is still 1, but now 1/2 is the adjacent side, and root 3 over 2 is the opposite side. So sine of 60 degrees, again, sine is opposite over hypotenuse. So that'd be root 3 over 2 divided by 1, or root 3 over 2. Cosine of 60 degrees would be adjacent over hypotenuse. Relative to the 60-degree angle, 1/2 is the adjacent side, and 1 is the hypotenuse. So notice from 30 and 60 are complementary angles. All right, and the sine of 30, 1/2, is the same as the cosine of 60, the complementary of the sine of 60. Those are the same values. And the sine of 60 is root 3 over 2. The cosine, and that's the complementary function, has the same value. The complementary function of the complementary angle has the same value. Let's see, tangent of 60 degrees would be opposite over adjacent, which is root 3 over 2, divided by 1/2, which is root 3. Cotangent of 60 degrees, maybe here we can use our reciprocal identities. Cotangent of 60 degrees is the reciprocal of tangent, 1 over root 3, which when you rationalize the denominator gives you root 3 over 3. Secant of 60 degrees is the reciprocal of cosine, 1 over 1/2, which is 2. And then cosecant of 60 degrees is the reciprocal of sine. So the flip of the sine be 2 over root 3. And when you rationalize the denominator there, you get 2 root 3 over 3. All right, so those are the special values of our trig functions that relate to our 30, 60, 90 degree right triangle, and that's where they come from. So when you see a table of values, these are where these numbers come from. There's another special triangle that we want to look at. It is what's called an isosceles right triangle. So an isosceles triangle is one where the it has 2 side lengths that are the same. Here it's going to be the legs of this right triangle. We're going to call that 1 and 1. So an isosceles, let's make sure, hopefully I can spell this right. Isosceles triangle has 2 side lengths that are the same, and an isosceles right triangle, these side lengths, these identical side lengths kind of surround a right angle. The hypotenuse of this right triangle, we don't know, but we can find it using the Pythagorean theorem. Know that 1 squared plus 1 squared is equal to x squared. So we have x squared is equal to 2. And then again, since we just need the positive root, since x is a side length of a triangle, we have x is the square root of 2. So now we have all of our side lengths here. Now we have 2 identical angles here. In an isosceles triangle, not only are 2 of the sides the same length, but 2 of the angles have the same measure. We know that whatever the measure of this angle is, 2 times theta plus 90 degrees has to add up to 180. And you can solve that to get that your angle theta has measured 45 degrees. So both of these angles here are 45-degree angles. And as you might be expecting, we can find the values of the trig functions for 45-degree angles. Right? So I'm just going to use this 45-degree angle as my reference. 1 is not only the length of the adjacent side, but it's also the length of the opposite side. And root 2 is the length of our hypotenuse. So when we go to find sine of theta, again, remember sine is opposite over hypotenuse. In this case, that's 1 over root 2. When you rationalize the denominator there, you get root 2 over 2. Same thing for cosine theta. Cosine theta is adjacent over hypotenuse. The numbers here are the same because the side lengths are all the same. So cosine of theta is also root 2 over 2. Tangent of theta is opposite over adjacent. Well, both of those side lengths are the same. So tangent of theta is going to be 1. And then we'll again use the reciprocal identities. Cotangent of theta, I'll more explicitly write it out here. Cotangent of theta is the reciprocal of tangent, which is 1 over 1, or 1. Secant of theta is the reciprocal of cosine. And I'll use this version of the fraction, root 2 over 1, which is root 2. And cosecant of theta is the reciprocal of sine of theta. Again, I'll use that version of the fraction, root 2 over 1, which is root 2. Okay, so those are, I guess, sorry, all these thetas should be 45 degrees here. As I'm filling in the 45 degrees for all of these thetas. Again, this is where these special values come from. We introduce a table of special values in our 6.2 notes. We'll also be discussing all these special values in the context of stuff that we're going to talk about next time in class. So these are where the values come from. If you were interested, at the end of the day, it's not too important to know where the values come from. It's definitely useful if you want to recreate these values, if you forget what they are and want to recreate these values. You know, knowing that they come from the isosceles right triangle, the 45-45 right triangle, as well as the 30-60-90 right triangle. And using your wits, you could maybe rediscover these values on your own. At the end of the day, though, these are values that you do ultimately want to have memorized. Okay, that'll do it for this video. Thanks for watching. If you have any questions, please let me know.